Continuing with partial fractions, we're going to look at algebraic division. So make some notes and then we'll look at an example. So hit pause when you're ready, hit play again. So this is our example. Looking at this algebraic fraction here, we've got to set it out in the form ax squared plus bx plus c plus d over x minus 3. In order to do that, we've got to divide x cubed plus x squared minus 7 by x minus 3. So if we use our bus stop, we've got x minus 3. And that goes into x cubed plus x squared. Now we don't have an x term, so we add 1 minus 7 because it's more difficult without having the x term there. Now what do I need to do to x to give me x cubed? I've got to multiply it by x squared. So x squared multiplied by x minus 3, that gives us x cubed minus 3x squared. Hopefully it's coming back to you from last year. If I subtract x cubed minus x cubed gives me nothing, and I've got x squared minus 3x squared, so it gives me 4x squared. I drop the naught x down here, so plus 0x. Now what do I need to do to x to give me 4x squared? Multiply it by 4x. And I do 4x times x minus 3 gives me 4x squared, as I've engineered it that way. And then 4x times minus 3 is minus 12x. Subtract again, they cancel. 0 minus 12x gives me 12x, and then I drop the minus 7 here. So what do I need to do to x minus 3 to give me 12x? Multiply by 12, so it's plus 12. And if I multiply x minus 3 by 12, I get 12x minus 36. The 12's cancel. Minus 7 minus 36 gives me 29. So now I've got this expression in a slightly different way. I can write it as x cubed plus x squared minus 7 all over x minus 3. That's equal to x squared plus 4x plus 12 from here, plus, now this is the remainder. Now the remainder goes over the divisor, so that's going to be plus 29 over x minus 3. Now when I look at the question, it says find the values of a, b, c and d. It's exactly in that form. So that tells me that if I equate the coefficients, a is equal to 1, so therefore a equals 1, b is equal to 4, c is equal to 12, and d is equal to 29. Job done. So time for you to make some notes, and we'll look at another example. So hit pause when you're ready to move on, hit play again. So this is another example. It's different, but somehow it seems familiar. So given x cubed plus x squared minus 7 is equivalent to ax squared plus bx plus c times x minus 3 plus d, find a, b, c and d. So first things first, looking at that, I need to eliminate 3 of those, so it helps me find 1, like 3 unknowns. What can I let x equal to get rid of 3 of those? I can get rid of those 3 and 1. If I let x equal 3, then that gets rid of this term and I'm left with d, so everything on the left hand side equals d. So let's do that. That's going to give me 3 cubed plus 3 squared minus 7 is equal to d. So we got 27 plus 9 minus 7 is equal to D. That implies then that D is equal to 29. Good. So we got D. It's vaguely familiar. Let's go again. This time I'm going to let x equal, if I let x equal 0, then A and B disappear. So I'm left with C and D, but I know D, so I'm just left with C. So let's do that. Let x equals 0. So that leaves me with 0 plus 0 minus 7. So minus 7 is going to be equal to A is 0. First term is 0, second term is 0. So it'll be C times minus 3. So minus 3C plus D, which I know is 29. So I think the best place for the C is on the left hand side, and bring the 7 over. So that gives me 3C is equal to 29 plus 7. 3C equals 36. So C is going to be equal to 36 divided by 3, which is 12. In order to find A and B, I'm going to compare coefficients. So first I'm going to compare coefficients of x squared. Actually, I'm going to compare the coefficients of x cubed. In the first instance. On the left hand side, coefficient of x cubed is 1. So I'm going to say 1 is equal to, on the right hand side, when I expand the brackets, I get 1x cubed, because that would be x times ax squared. So it's ax cubed. So it's simply a equals 1. Oops, capital A equals 1. And then I'm going to compare the coefficients of x squared, which will give me b. On the left hand side, I've got just the x squared, so again 1 is equal to, on the right hand side, I've got ax squared times minus 3 gives me minus 3ax squared. So I've got a minus 3a, oops, I don't need the x squared, it's just the coefficients. But also, when I multiply the x times b, I get bx squared. So the coefficient there is b, so minus 3a, add b. Now I know a is equal to 1, so I've got 1 equals minus 3 plus b. 3 goes over the other side, becomes positive. That means that b is going to be equal to 4. So I've now got a equals 1. Whoops. Let's undo that. Let's go again. So that means a equals 1. B is equal to 4. C is equal to 12. And D is equal to 29. Let's just make a little bit more room on the page. So I can rewrite the initial expression which we were given as x cubed plus x squared minus 7 is equivalent to a is 1, so that's x squared, b is 4 plus 4x, c is 12 plus 12 times x minus 3 is equal to plus d plus 29. Now that's very similar to the first example, and if I were to divide all the way through by x minus 3, So divide every term by x minus 3, I get x cubed plus x squared minus 7 divided by x minus 3. If I divide this term by x minus 3, it cancels that one there. So that gives me x squared plus 4x plus 12 plus 29 divided by x minus 3. And that, I believe, is exactly the term we had in the first example. So it's just a slightly different way of solving it. Good. So hit pause, make some notes. When you're ready to look at the next example, hit play again. Right then, the final example. Got to express this term, this algebraic fraction, in terms of ax squared plus bx plus c plus dx plus e all over x squared plus 2x minus 3. So that's going to be a division, algebraic long division, which will give me the first 3 terms and then the remainder. So if we set it out, I've got x squared plus 2x minus 3, and that goes into x to the power of 4 plus x cubed. I don't have an x squared term, so I'll write plus 0x squared plus x and minus 10. Now I need to divide, so I'll complete my bus stop. What do I do to x squared to give me x to the power of 4? I multiply it by x squared. So x squared times all 3 terms in turn. X squared times x squared is x to the power of 4. X squared times 2x gives me plus 2x cubed. X squared times minus 3 gives me minus 3x squared. And a bit of subtraction. Those 2 terms cancel each other out. X cubed minus 2x cubed gives me x cubed, minus x cubed rather. 0 minus 3x squared gives me plus 3x squared. I drop the x down here, plus x. So what do I do to x squared to give me minus x cubed? Multiply it by minus x. Minus x times x squared minus x cubed. Minus x times 2x minus 2x squared. And then minus x times minus 3 gives me plus 3x. Again, subtraction. Those 2 cancel. 3 minus 2. 3 minus minus 2. So that's going to be 5x squared. 1 minus 3 minus 2x. And don't forget the minus 10. So to get from x squared to 5x squared, I'll also multiply by 5. 5 times x squared is 5x squared. 5 times 2 gives me plus 10x. And if we hit the pause, and moving on, we've got to do 5 times minus 3, so that gives me minus 15 here. Okay, subtraction again. So minus 2x minus 10x minus 12x minus 10 minus minus 15 gives me plus 5. So we've got our term, so we can express it in terms of the original algebraic fraction. So if we say x to the power of 4 plus x cubed plus x minus 10 all over x squared plus 2x minus 3 is equal to x squared minus x plus 5 from here, Now they want us to have a plus here, so we can say plus and we've got minus 12x plus 5 all over x squared plus 2x minus 3. So this means that a is equal to 1, b is equal to minus 1, c is equal to 5, d is equal to minus 12, and e is equal to 5. And that's job done. So 3 examples. Now is making some notes on this example. If you want to hit pause, and then when you're ready, you can do some questions for me. So hit pause when you're ready, hit play again, and you can have a look at the questions. So it's exercise 1F on page 16, and you've got 10 questions altogether, 8 on this page, and finishing off with 2 more on the following page. So good luck.